Good morning, everyone. Today we will discuss about the analog circuits. In analog circuits also, majorly we are discussing about the operational amplifiers. So operational amplifiers will play major role in the analog circuit subject. So the prerequisites for this analog circuit subject are electronic devices and semiconductor devices. So in this, why? Because it is called analog circuits means, so the one and only IC analog IC is the operational amplifiers. That's why we'll discuss about the operational amplifier. So in this session, we will learn the basic concepts, characteristics, and applications of the operational amplifiers used in the electronic systems. So basically, operational amplifier is a high gain DC coupled amplifier with differential inputs and single output. So generally, any device is having only single input, but operational amplifier is having differential inputs. It is having two inputs and single output. So because of its performance, it is widely used in the analog electronic circuits. So operational amplifier. So simply it is called as op-amp, op-amp, and it is available in the form of IC, integrated circuit. So the topics under operational amplifier are introduction about operational amplifier and some basic information and ideal op-amp and block diagram representation of the operational amplifier and operational amplifier characteristics and 741. This is nothing but the IC number of operational amplifier and its features. So basically, why we are discussing about this integrated circuit means this analog circuit means this operational amplifier is available in the form of integrated circuit. So that's why just a brief introduction about this integrated circuit. So integrated circuit nothing but it is a miniature low cost electronic circuit consisting of several passive and active components. So these are built on a single block or chip that is called integrated circuit. And see, these are the IC packages. So IC not only op-amp, ICs are available in various packages. Those are metal can package, dual inline package, flat package. So dual inline package. Dual inline means it is having two equal lines on both sides, and we can identify in the number in that ICs by identifying the notch present in that package. And this is the flat package, and this one is the metal can package. So IC can be available in any package. The here operational amplifier is available in the form of dual inline package. So advantages of ICs are low power consumption. Mainly, it reduces the cost, increases the reliability, and it will improve the operating speed also. And coming to this integrated circuit ICs, ICs are majorly two types: analog integrated circuits and digital integrated circuits. So our IC is the analog IC. Our operational amplifier is belongs to the analog integrated circuits. So analog integrated circuit means it is said to be linear if there exists any linear relationship between its voltage and current. So IC 741, this is nothing but the number of op-amp, IC number of op-amp. It is available in the form of 8-pin dual inline package. And this is the example for analog IC, or it is also called the example for linear IC. And coming to the digital ICs. Digital ICs means those are working on only zeros and ones. Means that particularly that input may be either 0 or 1. But analog IC, those are having the input signals, continuous signals. Those are having the nature, analog nature input is. So our IC is comes under analog IC, or it is also called linear IC. So operational amplifier, simply this is also called op amp. It is used to perform in the various linear, non-linear and mathematical operations. So operational amplifier is a direct coupled high gain amplifier, and it is used to amplify both AC and DC signals. Generally, amplifier means it is used to strengthen the input signals. Means it will increasing the level of the amplitude level of the input signals. Coming to this operational amplifier will do amplification as well as it will do the operations on the that too mathematical operations on the analog signals. Because of this reason only, the amplifier is called operational amplifier. It can do amplification and it can do mathematical operations also. And it can amplify both AC and DC signals. So coming to the construction of operational amplifier. Operational amplifier consisting of differential amplifiers, level translator, and output stage. So in this first stage is the differential amplifier. So in this it is having two input terminals. The name of the two input terminals are, one is inverting terminal and another one is the non-inverting terminal. Just this is the basic construction. And characteristics of the operational amplifier. It is having some characteristics. Those are open loop voltage gain, output offset voltage, CMRR, common mode rejection ratio, slew rate, and output offset resistance also. These are the some characteristics. So coming to this, next one is the operational amplifier block diagram. So this one is the operational amplifier block diagram. So already I told you operational amplifier is having two inputs, not single input. So those two inputs are terminals names are inverting terminal and non-inverting terminal. So the first stage of this operational amplifier is the dual input balanced output differential amplifier. So the name is differential amplifier, means at a time it can accept the two input signals and it will take the difference of the two input signals. So dual input balanced output means it is accepting the two input signals, and similarly balanced output means the output is also taken from the two pins. Means we are collecting the output from the two locations. So that's why this is called dual input balanced output differential amplifier. And the next stage is the intermediate stage. So for this intermediate stage, we are using dual input unbalanced output differential amplifier. Means it can accept the input signals from the two locations, and but the output is only single output. That's why it is called unbalanced output. So dual input means it is accepting the two input signals. Balanced output means will take the output from the two locations, and unbalanced means we are receiving the output only at one particular terminal only. And next stage is the level shifting stage. So already I told you operational amplifier is the direct coupled high gain differential amplifier. So therefore there is a need for shifting the signals. That's why the third stage is the level translator. It is used after the intermediate stage to prevent the undesired DC current in the load and increasing the permissible output voltage swing. So for this stage, we are using the emitter follower for constant current source. So for this stage, to shifting the signal getting from the intermediate stage, and the output of that level shifter is given to the output stage. For this output stage, generally we are using the complementary symmetry push-pull amplifier. So the final stage is usually push-pull complementary symmetry amplifier. It is used to increasing the voltage swings and raises the grounding supply capabilities of the op amp. So this is the well-designed output stage providing the low output resistance. So this is the block diagram of operational amplifier. So basically it is a high gain differential amplifier, direct coupled high gain differential amplifier. The block diagram consisting of four stages: input stage, intermediate stage, level shifting stage, and output stage. For the input stage, we are taking the two inputs from the two terminals. Those are from inverting and non-inverting terminals. And the output is also taken from the two terminals. And intermediate stage is accepting the input from the two terminals, but the output is only single one. And this is given to the level shifting stage. For this level shifting stage, we are using the circuit emitter follower. And finally, to increasing the level voltage levels, we are using the complementary symmetry push-pull amplifier. Yes, this is about the block diagram of operational amplifier. See, this is the structure for the differential amplifier. And this differential amplifier is the basic building block of operational amplifier. If you observe, the first stage is a dual input balanced output differential amplifier, and the second stage is also dual input unbalanced differential amplifier. So this is the dual input means just we are taking the input from the two terminals. See, this is the one and this is the another one. Um, so balanced output means we are collecting the output from the two collector terminals, two output terminals. Depends on the configuration. So here the two transistors Q1, Q2 are having the ideal characteristics, and the resistances are also equal. That is RE1 equal to RE2 and RC1 equal to RC2. This is about the block diagram of differential amplifier. In next session, we will discuss about pin diagram and symbol and the remaining characteristics of the operational amplifier. Thank you.